Chapter 9.6 Transform and Trigonometric Graph. Before I discuss, I just want to do a small correction. In a previous slide, in the last around 1 minute, I did a minus 135. When I add 360, I answer as I think 215. Then this answer has to be not 215, 225. Then I add to 250 316 and I think I answered 575 because since this is wrong, this has to be 225 plus 360 has to be 585. So those are then sign I wrote this is equal, so it has to be 225 and 585. And transform it to geometric graph. There's not much difference between a normal graph and a trigonometric graph. Um, we discuss simple translations on horizontal and vertical axis. Um, if we consider the graph y equal fx, then if we want to move horizontally up or down, then it's going to be um, a plus fx or fx plus a. If a greater than 0, a equal to 0 and a less than 0. If a greater than 0, we are shifting up. A greater than equal to 0 is the same graph. A less than 0, we are moving vertically up or down. If we have an equation y equal x squared, then I will write this is fx equal x squared. Then when a equals 0, same fx equal fx. This is y equal x squared graph. This is x-axis and this is x square over y-axis. Now, if I write like this, y equal fx plus 1 or 1 plus fx, it means I have to shift this graph by up. It means this graph by up. So then this point to be, this is 0, 0. Now this point to be 0, 1. Shift by up by 1. If it is minus, like y equal minus 1 plus fx, then I have to bring this fx graph unit 1 to the down. So this is y equal minus 1 plus fx. This is y equal x square, or this is fx equal x square. This is y equal fx equal x square. This is y equal 1 plus fx. The same way, assume we have a graph y equal sine theta. So I draw the graph like this. This is 90, 180, 270, 360. So the graph is going to be sine graph. It will go minus, okay, actually. So this is y equal sine theta graph, and I draw in curve. So this is the y equals sine theta graph. Now it's going to be a vertical transformation. How do you draw y equal 1 plus, okay, 4 plus sine theta? I'll make it into 3 because it's difficult to draw it here. Now it means I have to shift like this. 1 plus means I shift by 1. It means I have to shift this whole setup by 1. It means now this is, we know that this is plus 1 line. This is minus 1 line. Now plus 1 line, what is the location of plus 1 line? Now y equal, the graph is y equal 3 plus sine theta. So sine theta graph we want to shift up by 3. It means plus 1 you have to shift up by 3. When you do plus 1 line become which line? Plus 1 plus 3 plus 4. 1, 2, 3, 4. So this is going to be this line. Now it is here. Let's say I will take this is A line. Now this is the new A line, A dash. And this line, minus 1 line. Minus line is going to be minus 1 plus 3 is 2. It is going to be here. If I talk, this is B line. So then this is the B dash. And this line, middle line is at 0. So 0 plus 2 is, plus 3 is 3. So then this is the middle line. And this is 90 line, 180 line. This is 270 line. This is 360 line. So now each and every point, so I have to add each and every point to this height, 3 units. When I add 3 units up, when I add to this point, what is the y height of this one? 0. 0 plus 3, it's going to be here, this point. Now this point, the shadow of this one is this one. How about this one? This is 1. Y 91. The coordinate of this one, 91. Now this is going to be 90. 1 plus 3, 94. It is here. Basically, you are shifting y value by unit 3 up. So the graph is then going to be like this. So this graph is y equal 3 plus sine theta. There is no difference between this one. If it is minus 1, y equal, so y equal sine theta, y equal 3 plus sine theta we done now. How about this one? Y equal minus 1 plus sine theta. Then we have to bring everything 1. It means the graph is going to be, this is minus 2 line. This is, right? Graph is going to be something like this. This is y equal minus 1 sine theta. Shift 1 by 1 down. So this translation is vertical translation. Y equal a plus fx according to a value. So this is up or down. This is vertical translation. Now we'll discuss the horizontal translation. And assume graph we have y equal fx, then y equal fx plus alpha. What will happen? This kind of setup. Assume you have equation y equal fx equal x square minus 5x plus 6, which is x minus 2, x minus 3. So the graph is going to be like this. 2 0 and this is 3 0, x and y. 2 0 and 3 0. Now I want to draw y equal fx plus 3. How do we do this one now? Okay, first of all, actually I'll go x equal minus 2. What kind of translation is here? So it is going to be a horizontal translation. So x minus 2 equals 0, x equal to, it means this graph is shifting 2 units to right. It means 2 0 become 4 0, 3 0 become 5 0. So now this is the new location of this graph. This is the new location of this graph. So we shift x minus 2, then shift to right. If you see y equal fx plus 1, it means you have to shift this graph by unit 1 to left. X plus 1 equals 0, x equal minus 1. It means you have to shift this graph by unit 1 to left. If this is minus value, so it is moving to right, and it is positive value, it is moving to left. So the same way, so this graph is y equal sine theta. Now y equals sine theta minus alpha. How do you do this one? What is the command is given? Every x values of the coordinate has to be shift by alpha. Assume that these coordinate, right? This is 0 0. This a coordinate that is going to be let's say 30 and y 30a, and this is 90 91, and likewise I'll take only that one. Now what is the x coordinate? This one, 0 30 90. It means now instead of 0 0, now its starting point is alpha 0. It means this point is shift by alpha length, like 38. This point is shift by alpha, and 90, this is going to be 30 plus alpha a, alpha 0, and this plus 90 plus alpha 1. From here to here alpha unit, it means this alpha unit to right. So now the graph is going to be like this. Okay, more than 360. Graph is going to be like this. I shifted this graph by alpha unit to right. it doesn't matter cos theta or tan theta. That's what you need to do accordingly. You have to shift. If it is negative, assume this is y equals sine theta minus 30. It means sine graph. You have to shift by 30 degrees to right. Earlier 0, 0, this point was on 0, 0. Now the same point was on 30, 0. That's the meaning of it. And sine theta plus 60, it means you have to shift this same graph by 60 units to left. 60 units to left. Now, my question is, this is sine graph. So this is 90. If this is sine 30, I want to shift this point to here. Then what is the graph should be? I mean, I am moving 90 degrees to right. It means y sine theta minus 90. If I want to bring this point to up to here in this place, I mean I am shifting it is 90 to left. Then y equals sine theta plus 90. Those are the horizontal movements. Let's discuss vertical stretch. Assume y equal fx, then we already discussed y equal a plus fx and y equal translation fx plus a. This kind of. Now y equal fx and y equal a fx. So if you see, this one will affect to not x values, y values. Now the y value is here. If it is 1, now this is a times 1. If a is 2, now it is going to be 2 times 1, 2. If a is going to be half or 0.5, if a is 0.5, then it is going to be 0.5 times 1, 0.5. So this is vertical stretches. If we consider this graph, y equal fx equal x minus 2, x minus 3 graph. Then what will happen if 2x? First of all, I'll draw fx. Fx is going to be this is 2, 0 and this is 3, 0 and this point is 0, 6. When x equals 0, that value is 6. Now what will happen if 2fx, y equal 2fx? It means y equal 2 times this value. Still the roots are roots, 2, 0, and then what is the difference? Now when x equals 0, this is going to be 6. 6 times 2, 12. Now it is become here 0 and 12. Basically, this y value, this height is 6. 6 double 12. So all the y values you are doubling. All the y values, when you double this y value, this will become more negative and this is more negative. And 0 double 0 still. That's why it is going, because the coordinate of this point is 0. Y value is 0. 0 double 0. That's why it's going in the same point. So you will get a curve like this, still going in the same point, but the y values are doubled. Now let's discuss y equal sin x and y equal to sin x. This is y equal fx. This is y equal to fx. Now this is sin x graph. This is x. This is sin x graph. Now I'll consider this point. Now I'm going to draw 2 sin x. Okay, what will happen to this point? 0, 0. So we are doubling y values, not x values. So 0, 2 times 0 is 0. Still this point is going to be here. So this is plus 1 and this is minus 1 and this is minus 2. This is plus 2. We know that sign is, the range of the sign is minus 1 and plus 1. It will bounce in between minus 1 and plus 1. What is this point? This point is 91. Then this is 2 times. It means 90. The y value will get double. This is 6 double. Likewise, y value, this is 1 double 2. Then 92. When it is 90, not 1 anymore, it is 2 here now. I can prove that one as well from here. When x equal 90, so y equal 2 times sin 90. 2 times sin 90 equal 1. It's mean 2. So that's all. So you can find like this. And this is 180. Then this is point is going to be, okay, I'll draw this bit. So what is the coordinate of this one? 180. Then 0 double is still 0. 180, 0. And then still this point is valid point for this curve. So it is going like this. Then what is the y value? 270. This point is 270 minus 1. Same way this point is 270 minus 1. Then 270 y double minus 2. Then this point is going to be here now. Curve is going to be here, and then this is like this. This is y equal to sin x. Can you guess y equal half a sin x? It means this value is going to be half. All y values half. It's going to be here, going like this, half, and like this. This is y equal half a sin x. What will happen? This value, this is this graph, y equal minus fx. What kind of difference you are expecting? It means it will give a command to all y values to switch the sign, not the x value. It means this positive y become negative y's, negative y become positive y's. It means so this is so this is the curve fx minus 2. Then it will turn the other way around, and this is what we call the reflection of x-axis. Same way, y equal minus sin x. So this a value is become not 2 or not half, minus 1. Then what will happen? This sine curve is going to be, this is the sine curve. So it's going to be all the y values, positive y values become negative y values, and negative y values become positive y values. So this is y equal minus sin x. In other way, it is a reflection of y sin x, y equals sin x. Actually, this line is bit. This is the line. Right. So this is y equals sin x. This is y equals sin x. And this is the negative sin x. All positive y values, positive heights become negative height. Negative height becomes positive height. So it switch. So vertical stretch finally not affect on x values, only y values. It affect y values, not the x values. In that case, horizontal stretch is affect to x values. Let's discuss horizontal stretch. That is y equal. Let's consider y equal fx, then y equal fax type. According to the a, what kind of difference we can see, kind of changes we can see in the graph. We can see that this graph horizontally stretch according to the a values. For example, if assume fx equal x, then so this is fx equal x. I will consider f2x, which is 2x. Now x equal 100, fx equal 100, because x value is 100. Now here, to get 100, here when I put x equal 100, I will get 100. Now to get 100, I need to put not x equal 100, x equal 50. 2 times 50 is 100. So you don't need to go to the town center to bring the bread. You can find a bread in a shop near to you. So this is 100, very far. The same qualities you will get with the 50 meter when x equal 50. Let's consider a curve like this. Fx equal x minus 2, x minus 3. Now what are the root? X equal 2 and x equal 3. Now we'll find what is f. So this is fx. f2x. f2x mean every area x I'll put 2x minus 2, 2x minus 3. Instead of x I'll put 2x. Then what are the roots now? 2x minus 2 equals 0, x equal 2x equal 2, x equal 1. This is 2x minus 3 equals 0, x equal 3 over 2. This 2 0 root, right, you can find now where? 1 0. The same root you can find at 1 0. Y values is going to be the same. So this is 1 0. And 3 0 root now you can find 1.50. 1.50. Y value is going to be the same. Now what will happen? What kind of graph you will see? This kind of graph. Right? This is y equal 2x. This value you bring to here, this value you bring to here. Assume this kind of graph you have. This is a normal graph. Right? This is A, B, C, and D. This point A, B, C, D. Then this is, let's say, y equal fx. Then what is y equal f2x? F2x is going to be, you will get A here now. This is A. I put A dash. Right? And B here now, B. This point will be here. This is A dash, then this is going to be B dash. B, I bring it here, new B, oh you can tell that. Then this is going to be something like this. Right? You are stretching this graph. Yeah, like this. Not a stretching, if x equal 2, it a value is 2, you are squeezing the graph. If a value is half, you are then stretching. So this kind of idea you want to get. And another special location, f equal minus x. What will happen if you put minus x? It means you are changing all positive x value to negative, negative x value to positive. If you submit plus 3 become minus 3. If you put minus 4 here, minus 4 become plus 4. It's going to be here. It means you will get a reflection of y-axis. If this is fx, what is f minus x? F minus x is going to be, this is going to be 2, something like this. So this is going to be minus 2, 0. This is going to be minus 3, 0. It is a reflection of y-axis. Same as this is okay, y equal sine x. Then what is y equal minus sine x? So this one, sine minus x. That's going to be like this. It is a reflection of y-axis. This is going to be same. This point is here, and this is going to be like this and like this. Right? So reflection. My graph is not symmetric, but it has to be the same. This graph reflection on y-axis the other side. This is x, and now this is sine x graph. Y equals sine x. Now we'll do y equals sine 2x. Y equals sine x and y equal sine 2x. What kind of difference? I'll consider 1 point. 0, 0. I know this is only effect for x value, not y value. Okay. But okay, we'll find it. Y equal, when x equals 0, x equals 0, y equals sine 2 times 0 is sine 0. Sine 0 is 0. It means 0, 0 point is 0, 0 point as it is. Right, so let's consider this one. 90 and 1. This is plus 1 and negative 1. What will happen? When x equal 90, y equals sine 2 times 90. Sine 180. Can you, by looking at, can you tell me sine 180 value? And sine 180 is 0. Or you can look at from the calculator. You calculate. So now here it is my 0, 0. Now what is the this matching? 90, but uh, when x equal 90, so x equal 90, y value is 0. It means this point is shifting to here. Right? It means the graph is going to be like this now. Another, we'll consider another point now. 180. When you consider y 180 0, what will happen to here? When x equal 180, y equals sine 2 times 180, which is sine 360. What is sine 360 is 0. Now this point stay the same, but it's going to be like this. And likewise, it's going to be like this. When you look at those 2 points now, this is sine 2x, y equals sine 2x graph. This is y equal sine x. When x equal 90, y is sine 90 equal 1. In y equal sine 2x graph, to get 1, when you put x equal 45, y equal sine 2 times 45, 90, which is 1. Now, in this graph, sine graph, you will get 1 at 90. But in this graph, you will get one value, the peak value at 45. This is another way of looking at it. Basically, you should have an idea. The graph is y equal fx graph. Whether it is uh, this form or x plus a. This is a vertical stretch, vertical movement. This is horizontal translation, and the other one is y equal afx, which will affect y values only. And part of this one, y equal minus fx, it is a reflection of x-axis. If this is a reflection of x-axis, and the other one is y equal fax. So it means you are stretching the graph with 1 over a scalar factor. And yes, if you see this kind of y equal f minus x, it means it is a reflection of y-axis. So this is effect to y, and this is effect to x values, not y values. This is a vertical stretch. This is horizontal stretch. This is vertical movements. This is horizontal movements. So sometimes you may get combination of this one. If you look at y equal afx plus b, then what is the meaning of this one? Fx graph and then vertically stretch by a and then shift up or down by b. B is positive up, V is negative. Likewise, it is a combination. So it is different for trigonometric and the non-trigonometric graph. This is up or down movement. This is left or right movement. This is vertical and this is horizontal straight. Minus fx mean reflection of x, and if minus x mean reflection of y.